You know, right now, as you're sitting there, there's an invisible war happening inside your body. It is a constant, silent battle against literally trillions of potential invaders. So who is this incredible protector, this personal army that works 24/7 to keep you healthy? Well, it's your immune system, and today we're going to pull back the curtain and see exactly how this amazing army works.
Think about that for a second. How does your body possibly defend itself against this constant onslaught of viruses, bacteria, parasites, all these things you can't even see? The sheer scale of that threat is almost impossible to wrap your head around.
The answer is you have this incredible, sophisticated, multi-layered guardian network. We're talking about your immune system. And it's not just one organ or one thing. It's this complex and dynamic system of cells, tissues, and molecules all working together. So let's break down how this army is structured.
Okay, our first stop is the front line, the immediate responders. This is your innate immune system. You can think of it like the guards on the castle walls. They're always there, always ready, and they provide this general, pre-programmed response to any broad threat they see.
This slide really splits our defenses into the two main branches. Over on the left, you've got the innate system. It's fast, it's general, it hits hard right away, but it has no memory. It treats every germ the same, every single time. Now, on the right, that's the adaptive system. It's a bit slower to get going, but it's a highly specific strategic force that, crucially, remembers its enemies. And that difference is the key to your body's entire defense strategy.
So, what's in this frontline toolkit? Well, first up, you've got your physical and chemical walls, right? Your skin, mucus, even things like stomach acid. But if something gets past those, your first responder cells, called phagocytes, rush to the scene. And their job is literally to eat and destroy the invaders. And you know that feeling of inflammation, the redness, the swelling? Turns out that's actually a good thing. It's the alarm system, a chemical call to arms that brings even more immune cells to the fight.
But what happens when an invader is just too tough for those frontline guards? Well, that's when the call goes out to the elite special forces of your immune system, the adaptive response. This is where the fight gets really personal and super strategic.
This, right here, is the absolute game changer. Unlike the innate system, the adaptive system doesn't just fight, it studies its enemy. It learns to recognize a specific pathogen. It adapts its strategy to fight it better, and, this is the most important part, it creates a memory of that fight so it's ready if that bad guy ever comes back.
So how does it know who the enemy is? It looks for something called an antigen. The best way to think of an antigen is like the enemy's uniform or its flag. It's a unique molecular signature on the surface of a pathogen that just screams, "Hey, I don't belong here." And the ability to tell these non-self antigens apart from your own body's self molecules is absolutely fundamental to this whole process.
So who are these elite soldiers? Well, meet the two main players, B cells and T cells. B cells are kind of like mobile weapons factories, churning out specialized proteins to fight invaders. T cells, on the other hand, they're the ground troops. They get into direct, hand-to-hand or cell-to-cell combat.
Now these B and T cells don't just charge in blindly. They have two very distinct, very coordinated strategies of attack, and it all depends on where the enemy is hiding.
And this table lays it out perfectly. On one side, you have humoral immunity. This is led by B cells, and it targets bad guys that are just floating around freely in your body fluids, like your blood. It's an antibody-driven attack. But then you have cell-mediated immunity. This is led by the T cells, and their job is to hunt down the traitors, your own body cells that have been hijacked by a virus or have turned cancerous. They hunt down these compromised cells and eliminate them directly.
So what exactly are these weapons the B cells make? They're called antibodies, and they are these amazing Y-shaped proteins that act like custom-made, heat-seeking missiles. Each antibody is designed to recognize and lock onto one and only one specific antigen. Once it's attached, it can either neutralize the threat all by itself or act like a big bright beacon, marking the invader for destruction by other immune cells.
The T cells approach is, wow, it's even more direct. So when one of your own cells gets infected, it does something amazing. It actually takes a piece of the invader, an antigen, and puts it on its own surface, like a distress signal. A killer T cell is constantly patrolling, and if its receptor matches that specific antigen, it locks on, releases these deadly toxins, and destroys the infected cell, stopping the virus from making any more copies. It is an absolutely precise surgical strike.
This whole system is just incredible. But it's got one catch. It needs to see an enemy at least once to learn how to defeat it. So, what if we could train the army before the real invasion even happens? Well, that's exactly where vaccination comes in.
This is the million-dollar question, isn't it? The question that medicine has been trying to answer for centuries. How do you give your highly specialized adaptive immune system the advantage of experience without having to actually get sick first?
And the solution is so simple in concept, but absolutely brilliant in execution. A vaccine is essentially intelligence for your immune army. It's the enemy's playbook. It's a training manual that prepares your special forces for what they're about to face.
So here's the trick. A vaccine introduces a safe, totally harmless version of the pathogen's antigen into your body. It's just the uniform, not the actual bad guy. Your adaptive system sees this uniform, thinks it's a real threat, and mounts a full response. It creates B cells, T cells, and most importantly, an army of long-lasting memory cells. You get all the training with none of the sickness.
And that brings us to the ultimate payoff of this entire incredible system, whether you got it from a natural infection or a vaccine, the power of immunological memory. This really is the superpower of your adaptive immune system.
Immunological memory is the whole reason you usually only get diseases like chickenpox once. After that first encounter, your body keeps a standing army of veteran B and T memory cells that remember that specific bad guy. So if that same enemy ever dares to show up again, these cells are ready to launch an immediate, overwhelming counterattack. And this chart just shows you how huge that advantage is. That first bar, that's your first time seeing a pathogen. The response is kind of slow, a little weak, but look at that second bar. Whoa! That's the secondary memory response. It's not just a little bit faster, it's lightning fast and unbelievably stronger. It's so effective that you often wipe out the pathogen before you even know you were exposed.
And that power, the ability to create memory whenever we need it, is why this quote is so on the money. By safely teaching our immune system what to look for, we've created one of the most powerful tools in the history of public health. We are literally actively harnessing our body's own incredible defense system. So in the end, your immune system is a learning machine. It's a biological record of every single battle you've ever fought. And when we help our systems learn, we aren't just protecting ourselves, we're contributing to a defensive shield for our entire community. So the question becomes not just what you will help your system learn, but how that collective memory can protect us all.